Episode 56, Real-World Uses, Dividers in Practice, Crash Course Instrumentation, Series Circuits and Amp, Voltage Dividers. Hook want to tame a wild 12-volt signal into a friendly 3.3-volt input, set a clean threshold, or read a light sensor without the math headache? Today you will see where voltage dividers quietly run the show and why they fit. One-line memory. A divider turns an input voltage into a chosen fraction of that input. Say it out loud. Output equals input times the share you picked. Use case 1. Scaling into a meter or ADC, why it applies. You have more voltage than your meter or converter can handle. A divider shrinks the range, so you can read the full story without clipping the peaks. Pick it when your destination barely sips current, and accuracy matters more than raw power. Use case 2. Dial a set point with a knob, why it applies. Sometimes you want a feelable threshold. Turn a knob until an alarm trips or a graph hits the sweet spot. A potentiometer as a divider makes the output track your hand in a straight, predictable way. Add buffering only when the next stage starts to tug on that setting. Use case 3. Sensors that change resistance, why it applies. Light, heat, force. Many sensors change resistance as the world changes. A divider translates that change into a voltage your brain or microcontroller understands. Choose it when you care about trends and ranges more than absolute lab-grade precision. Use case 4. Battery watching without killing the battery, why it applies. You want to peek at the fuel gauge without taking a big sip. A sleepy divider lets you sample the battery with almost no drain, especially if you only check occasionally. Great for portable or standby gear where battery life is king. Use case 5. Gentle level shifting, why it applies. Need a 5-volt signal to talk to a 3.3-volt input? A divider nudges the level down safely when signals are modest speed and the input is easy to drive. If you are doing high-speed logic or precision timing, reach for a dedicated level shifter instead. Use case 6. Quiet midpoints and bias references, why it applies. Audio, sensor bridges, and single-supply amplifiers often need a calm middle ground between power rails. A divider provides that park bench voltage so signals can swing up and down cleanly. Sanity cues and amp. Gotchas. No wiring. Just what to watch for. If the number drops when you connect the next stage, that's loading. Your destination is borrowing too much. If parts feel warm for no good reason, your divider is wasting power. Values are too low for the job. If the reading jitters, your values are probably too high for a noisy world. Buffer or smooth the signal. If you are tempted to power something from a divider, pause. Dividers set numbers well, they do not deliver juice. If ratios must be dead on, mind tolerance and temperature, the divider's superpower is the ratio, not the absolute values. History nugget, fun and fast. Early radios used divider networks to bias vacuum tubes at their sweet spot, so the audio stayed clean. In labs, slide wire potentiometers. Let engineers dial exact voltages without loading the circuit. Everyday dividers with rulers attached. Recap. Dividers scale, set thresholds, sense changes, watch batteries, shift gentle logic levels, and create calm midpoints. When accuracy or stability matters, buffer. When battery life matters, sample lightly. Next episode, a combined review and wrap-up, pitfalls to dodge, quick spice checks, and fast sanity tests you can do on any series or divider network. Thank you to Tony Kuphaldt and the open source community for the Mod L resources that inspire this series.